Hi students, last two videos discuss about the nanomaterial, nanotechnology, industrial chemistry, paper number 16. Previous two videos discuss about the history of the nanomaterial, nanotechnology. Second point is properties of the optical properties of nanomaterial, and previous video also discussed about the uh, top down and bottom up approaches and synthesis method of nanomaterial, 5 nanomaterial method. And in this video discuss about the characterization of the nanomaterial. Various method characterized technique used by the material is characterized the X-ray diffractometer, diffraction, neutron diffraction, UV visible spectroscopy, IR absorption spectroscopy, uh, Fourier transformation infrared, atomic absorption spectroscopy, nuclear magnetic spectroscopy, electron spin resonance spectroscopy. Few electronic microscopy also used. First is scanning electron microscope, that is same. Transmission electron microscope, TEM, and scanning tunneling microscope, STM, and atomic force microscope. These are the generally provide the information about this technique, or they provide the information about the morphology, size, structure, even image of atomic can be obtained from these method. From the these technique, few three techniques are discussed in this video. First is XRD, that is X-ray diffractometer. X-ray diffractometer is based on the constructive X-ray diffraction is based on the construction interference of the monochromatic X-ray and crystalline sample. These X-rays are generated by cathode ray tube filtered to produce monochromatic radiation, collimated to concentrate the and directed towards the sample, and the interaction of incident ray with the sample products to form constructive interference field condition of satisfy Bragg's law. This is the reflection and then reflection, that is Bragg's law. Construction of interference, that is n lambda is equal to 2d sin theta. Bragg's law verify this XRD XRD principle. Working of the XRD: first sample is formed and introduced and mounted on tip of the needle by gonimeter process, that is the sample, and the gonimeter, the collimator, the sample is here. The X-ray tube diagram: X-ray tube matched filter filament heating tube, cathode ray tube, and slits, filter slits, collimator, and the angle, and the detector. First a sample is formed and introduced and mounted on tip of the needle by gonimeter process. Then monochromatic beam of X-ray is bombarded on sample. This monochromatic beam is bombarded on the sample. Then the electrons surrounding the molecule diffract as the X-ray hit them, and then diffracted rays reaches to film, which is connected to detector, which is connected to this diffracted rays is hitted on the sample. Then the this film joined to detector. This form pattern, this type of pattern is called X-ray diffraction pattern. Each spot formed on the film are called as a reflection. Spot is known as a reflection. This diagram is sample, then the reflection. These reflection to detected by the detector. Second technique is simple electron microscope. In simple electron microscope, the primary electron beam on the primary electron beam is simple surface, sample surface pass on the sample surface, then the sample surface, then the secondary electron is removed, then next step going to back scattered electron, then the characterization X-rays, then the continuum X-rays, and last is secondary fluorescence. Back scattered spatial resolution and the X-ray spatial resolution. Most of these electron pass on the sample surface, then the secondary electron, this electron transmitted, and most of the X-rays are photon, most of the agar electrons and reflected back scattered electron, back scattered the electron detector and electrons. This is the working of the simple electron microscope. Scanning electron microscope, working and principle of the scanning electron microscope. These are the scanning electron microscope. First electron gun, then the electron lens. First electron lens condenser, second condenser, and third final lens aperture, that is the final lens aperture. The scanning coil, these are the scanning coil. Magnification, these electron beam pass to these lens to sample specimen and the vacuum chamber. This sample beam of electron pass to on sample, then to detect, amplifier and display CRT and scan generator and magnification control. The main component of typical SEM are the electron column, scanning system, detector, display, vacuum system, and electronic control in figure. The electron column of the SEM consists of an electron gun and two or more electromagnetic lenses operating in vacuum pump. The electron gun generates free electron and accelerate these electrons to generate in the range 1 to 40 kilo kV in the same. Purpose of the electron lenses is to create a small focused electron probe. These lenses are used the small electron focus on the sample, on the specimen. Most SEMs can generate an electron beam at the specimen surface with spot size less than 10 nanometer. Maximum size of specimen can be used up to 2.5 into 10 raised to minus 7 nanometer. In order to produce image, the electron beam is focused into fine probe, which is scanned across the surface of these spaces with the help of scanning coil. With the higher accelerating voltage and electron beam penetration is generated and the interaction with volume is larger. Next, therefore the spatial resolution of micrograph created from those signal will be reduced. So there will be brighter image because of the number of backscattered electron will be increases, but resolution will be worse. For secondary electron image at the typical voltages in 15 keV volt, backscattered electrons can be enter the secondary electron detector and degrade resolution because they come from the deeper in the sample. The electron beam interacts with the specimen to depth approximately 1 micrometer. Complexes interaction of the beam electron with the atoms of the specimen produces wide variety of the radiations. In such case, knowledge of the electron optics, beam of specimen interaction, detection and visualization process is necessary for the successful utilization of the power of the same. Advantages and disadvantages of same. Advantages: wide array of the application, gathering of the versatile information, user friendly operation, generation of data in digital form, minimal preparation of action, and ultra speed capacity. Disadvantages: this technique is expensive, larger, sensitivity toward the electric, magnetic, or vibration interferences, and requirement of the special training, limitation to solid inorganic sample. These are the disadvantages of the same. Second technique is electronic microscope, transmission electron microscope, that is the TEM. Transmission electron principle. Transmission electron microscope TEM is a microscopic technique whereby beam of electron is transmitted through an ultra thin specimen interacting with specimen, as it passes through, an image is formed from the interaction of the electron transmitted through the specimen. The image is magnified and focused onto imaging device such as fluorescent screen is used, and in same is a camera is used, and simple in, but in TEM fluorescent screen is used as a imaging the sample. On layer of the photographic film or to be detected by sensors such as CCD camera. Working of TEM, this block diagram of the TEM image: tungsten filament, anode, that is the total known as a electron gun, then condenser, specimen, objective lens, and projected lens, and final fluorescent screen and photographic film. Tungsten filament generates beam of electron that is the focused on the specimen by the condenser. The electron beam directly pass to filter the beam of light by condenser lens to direct focus on the specimen, that is the sample. Magnetic lenses are used to focus the beam. The column containing the lenses and specimen must be under high vacuum to obtain clear image because electrons are deflected by collision with air molecule. Sorry. Magnetic lenses form the enlarged visible image of the specimen on fluorescent screen. This is the fluorescent screen. Photographic film. The screen can also be moved aside and the image captured on the photographic film as a permanent record. Difference between same, that is scanning electron microscope, and TEM. First, the TEM, electron beam passes through inside the sample. Electron beam scan over the surface of the sample. Second, specially prepared thin sample are supported on TEM grid, but in a sample can be thickness and is mounted on the aluminum stub. Next, in TEM, specimen stage halfway down column, but in same specimen stage in the chamber at the bottom of the column. In previous two slides shows the block diagram. In same, specimen is bottom of the specimen space is bottom of the same diagram, and in TEM, first condenser lens. After the first condenser lens, the specimen is sample holder is there. Image shown on the fluorescent screen. Image is shown by the fluorescent screen, but in same image is shown on the TV monitor. Image is two-dimensional projection of the sample. Image is on the surface of the sample. That is these are the all difference between the same and TEM. Application of nanomaterial. First application, sunscreen and cosmetic. Nano-sized titanium oxide and zinc oxide are currently used in the some sunscreen, and as they absorb and reflect ultraviolet rays. Nano-sized iron oxide is present in the some lipstick and pigment. That is the color and the mixed with iron oxide is mixed with lipstick pigment, that is pigment. Second, paints. Thinner paint coating is used, for example on aircrafts, would reduce their weight, which could be beneficial to the environment. Third, displays. Flat panel displays as used in television screen and computer monitor is driving the development of some nanomaterials. Batteries. With the growth in portable electronic equipment like phone, mobile, laptop, remote sensor, there is great demand for the lightweight, high energy density batteries. That is the nickel metal hydride batteries are made of nanocrystalline nickel and metal hydride are envisioned to require less frequent recharging and to last longer because of their larger surface area. Fifth, catalysis. In general, nanoparticles have high surface area, and these nanoparticles with a high surface area and hence provide higher catalytic sites and activity sites. Sixth, medicine. Nanotechnology has been boon in the medical field by delivering drug to specific cell using nanoparticle. Nanotechnology can also help to reproduce, to repair damaged tissue. Also, bone can be regrown on carbon nanotube scaffold, and the use of gold in medicinal preparation is not new. In the Indian medical called Ayurveda, gold is used in several preparation. That is the this sensor of the gases. The gases like NO2, H2S, ethanol and NH3 etc. can be detected on the basis of increase in electrical conductivity of nanomaterial. Food. Nanotechnology can be applied in the production of processing, safety and the packaging of food. The canola oil by cement industry of Israel contain an additive called nano drops designed to carry vitamins, mineral and the phytochemicals through the digestive system. Next, agriculture. In agriculture, applications of the nanotechnology have the potential to change the entire agriculture sector and food industry, from the production to conversion of processing and packing, the transportation and even waste of treatment by the use of the nanomaterial. In energy, the most advanced nanotechnology project related to energy are storage, conversion, manufacture and improvement by the reducing material and process rates, energy saving and enhanced renewable energy sources. Commercially available in solar cell, have much lower efficiency, 15 to 20% efficiency of the solar cell. Nanotechnology could help increase the efficiency of the light and conversion by using nanostructure. Other applications, some commercial products on the market Today, utilizing nanomaterial including stain-resistant textile and reinforced tennis rackets. Companies like Kraft Food are heavily funding nanomaterial-based plastic packing. Food will be fresh longer if the packages is less permeable to atmosphere. These are the application of the nanomaterial. Thank you for listening.